Hello and welcome to all students. In this is the SYBSC class, SYBSC Mathematics class, and in this lecture we learn about unit number 3 applications, chain rule for functions in implicit form. Suppose z is equal to f of x comma y is a given in the implicit form f of x comma y comma z equal to 0. Now using chain rule we can write dou f by dou x into dou x by dou x plus dou f by dou y into dou y by dou x plus dou f by dou z into dou z by dou x. but we know that dou x by dou x has value 1 and dou y by dou x has value 0. So above equation becomes like this: dou f by dou x plus dou f by dou z into dou z by dou x is equal to 0. Okay. Now finally we find the value of dou z by dou x. So dou z by dou x is given by dou z by dou x is equal to minus, or let us take some space, dou z by dou x is equal to, let us take this derivative here, minus dou f by dou x and whole divided by dou f by dou z. Is it okay? Yes. So this is the formula for to find dou z by dou x, and similarly we can write okay. So this is the formula to find dou z by dou x. Now similarly we can write the partial derivative of z with respect to y, and it is equal to minus dou f by dou y and whole divided by dou f by dou z. Okay. So these are the two formulas to find the partial derivative of given function. Okay. If it is we can write in implicit form. Okay. Now let us take one example. Now let us take one example. Okay. Let us take one example. Example number 1: if x comma y comma z, if we have a function like this, x into y into z is equal to cos of x plus y plus z, then find dou z by dou x and dou z by dou y full stop. Okay, solution. Let us write the solution. If let us write solution. Let us write the given function like this: capital F of x comma y comma z is equal to x into y into z minus cos of x plus y plus z. Okay, now let us find. So from the above formulae, look at these two formulae. So in these two formulae we need partial derivatives of f with respect to x, y and z. Okay, so let us find these partial derivatives for x, where is y and z. Okay, so let us go to the partial derivative first now. So partial derivative of f with respect to x, partial derivative of f with respect to x is equal to, so f is here, with respect to x, y, z. Okay, minus and plus cos of x, plus sine of x plus y plus z. Okay, and then we find partial derivative of f with respect to y, and it is equal to this xz plus again sine of x plus y plus z, and then find partial derivative of f with respect to z. Okay, partial derivative of f with respect to z, and it is xy plus sine of x plus y plus z. Okay, now we find partial derivative of z with respect to x. Now write formula to find partial derivative of z with respect to x, and that formula is minus dou f by dou x divided by dou f by dou z, dou f by dou z, and it is equal to dou f by dou x is yz, or it has a minus sign, therefore a minus sign. Okay, so minus times minute I can write, and I can take this line up to here. Okay, minus times yz, it is into bracket, not necessary write in bracket, minus times yz plus sine of x plus y plus z. Okay, and divided by xy plus sine of x plus y plus z. So this is partial derivative of z with respect to x. Now we write partial derivative of z with respect to y. Now write partial derivative of z with respect to y is equal to minus times dou f by dou y and whole divided by dou f by dou z, and it is equal to okay, we write here equal to, on this line we have to write here minus sign, and dou f by dou y is xz plus sine of x plus y plus z, and divided by xy plus sine of x plus y plus z. So these are the two partial derivatives. Okay, so this is the chain rule corresponding to the implicit form of a function. Let us go to the next point of this unit, and the next point is a Lagrange method to find maxima and minima for the given function of two variables. Okay, so let us go to the next now. Next point of this unit is second derivative test for extrema of function of two variables. Okay, that is our new point here, second derivative test. Second derivatives test for extrema, extrema of functions of two variables. Functions of two variables. Just we state now here. Okay, so we state one proposition. Okay, so that proposition is so let us write now, let q of x comma y is equal to ax square plus b 2 times bxy plus cy square be a function of two variables, be a function of two variables, and let delta is equal to ac minus b square. Okay, and let us write the first condition. First condition says that if a is greater than 0 and delta is also greater than 0, then q at point x comma y is greater than 0 for all x comma y belongs to R2, and here x comma y is not equal to 0 0. Okay, now second is if a is less than 0 and delta is greater than 0, then value of this function q at x comma y is also less than 0 for all x comma y belongs to R2. And here x comma y is not equal to 0 0. And third condition is if delta is less than 0, then every open ball around origin there exists point x comma y such that x comma y is less than 0, and also there is a point x comma y such that delta is greater than 0. If delta is less than 0, then there exists open ball around origin there exist points x comma y such that value of x comma y is less than 0, and also there exist points x comma y such that value of point x comma y is greater than 0. So only conditions, one propositions I have stated here. Now we go to the next point of this unit, and the next point is Lagrange method. Next point is method of Lagrange's multipliers. Method of Lagrange's multipliers. Okay. Okay, so let us go to the function of two variables first. Okay, function of two variables. function of two variables. Okay, suppose let f of x comma y and g of x comma y is equal to 0 be given. Okay, and are differentiable functions be given. Differentiable functions be differentiable functions. Then to find the local maxima and minima, minimum value of f subject to the condition g of x comma y equal to 0, find the value of x, y and lambda that satisfies simultaneously that satisfies the equations. So I will write these two equations. Gradient of f plus lambda times gradient of g is equal to 0, and g of x comma y is equal to 0, or we can write the simultaneous equations are, or we can write this thing fx plus lambda times gx is equal to 0 and fy plus lambda times gy is equal to 0 with g of x comma y comma z is equal to g of x comma y is equal to 0. So solve these equations for x, y and check the maxima and minima. Check maximum and minimum. Value of f. Okay, so this is Lagrange method for function of two variables. Similarly, we can write Lagrange method for function of three variables. Just we have to introduce one variable z here. Okay, so now this is the end of our lecture, or okay, though this is the end of this lecture now. Thank you. Okay.